So in this presentation, we're going to look at some important definitions in probability. Okay, so first off, just an experiment is any process which generates various outcomes. So a coin toss experiment, that's an experiment. A survey, that's an experiment. Okay, just walking around asking people questions and so on. Dice roll, that's an experiment. Okay, outcome, one possible result for the experiment. So if you roll a die and you get a 6, that's an outcome from an experiment. Now, this one's interesting. Okay, sample space. And that is the set of all possible outcomes of an experiment. And we denote that S. Okay, so that's a big thing to learn here, sample space. And finally, event, any subset of the sample space. Okay. So let's just move on from that. So those two important definitions there just to get us going: sample space and event. Okay, and we'll sort of drill down into those. We'll sort of get a bit more of a sense of what we're doing there. Okay, so if an example of an experiment is flipping 2 coins. Okay, outcome, the results shown on the coins. The sample space is S equals all the possible outcomes we can get when we do the coin toss twice. Okay, heads, tails, heads, tails. Okay, so here's some examples that we can get, and these are all essentially just generate this. These are subsets of this. Okay, so at least one head showing, heads, heads, tails. Getting 2 tails, tails, same result on both coins, heads, tails, and so on. Okay, so those essentially, the events are just essentially subsets of the sample space. That's how we could look at it there. Okay, so let's go on down here. So, don't know what's going on here. Probability is the relative frequency of, oh sorry, it's gone now. The probability is the proportion, relative frequency, that a particular event occurs in the long run after repeating the experiment n times. So it's a very straightforward enough idea. So let A be the symbol for the event in question. The probability of A is essentially the number of times A occurs, or the number of outcomes contained in A, and the number of all possible outcomes in the sample space. Okay, it's a very simple enough idea, like how many ways do we get a success out of how many attempts, something like that. So these are what they call the axioms of probability, and this is a bit more important now. So probability must be between 0 and 1. So the probability of A, if the probability of A is 0, that means the event is impossible. Okay. The probability of 1, that means that the event is certain. Okay, that it's almost guaranteed to happen. Okay, essentially the probability of a measure is how likely that event is to occur. Okay, so essentially we just sort of get a sense of how likely an event is to occur by stating the probability. So for example, probability of 0.01 is a very unlikely event. 0.3 unlikely, 0.5 50-50 chance of it happening. Okay, that's like a heads or tails experiment. 0.7 likely, and 0.99 very likely. Okay, so let's move on. So here what we're doing here is we are flipping 2 coins. Okay, so the sample space, as we've seen earlier on, is heads, tails, heads, tails. Okay, and the number of possible outcomes there is 4. Okay, right. So consider the following event. The A is showing at least one head showing. Okay, so that's the event, the components of the sample space which relate to A. The event A is heads, tails, tails. Okay, so there's 3 elements there. So essentially what we're saying here is the probability of A is 3 out of 4, okay, which is 0.75, okay. Getting 2 tails, that was just one possible outcome out of 4, so 1 out of 4, 0.25. Likewise, we have 2 sample points here, so the probability of that is 2 out of 4, 0.5, it's a 50-50 chance. And likewise, the coins show different results. 2 sample points out of 4. 4 possible sample points, so the probability of that is 50% also. So, now this is an important one. So, for probability, the complement rule. This is going to pop up all over the probability course. So either the event A happens or it does not happen. So in the later case, A complement, pronounced A complement, well, just the complement of A or A complement, occurs instead. So the A complement is the event which is the opposite of A. Okay, so if you're rolling a dice, for example, rolling a die, and you can either get an even number or an odd number or something like that. Okay, so the complement rule says that the probability the complement A is 1 minus the probability of A. Okay, nice, simple, straightforward idea. So if there is a probability of A happening is 30%, that means the probability of it not happening is 70%. Something like that. Okay. So, for example, if the probability a light bulb fails is 0.05, then the probability that the light bulb works is 1 minus that, 1 minus 0.05, which is 0.95. So, very simple and straightforward enough idea about the complement rule. Okay. So, did I go too far there? No. So just a couple of questions there. Consider the experiment where a die is rolled and a coin is flipped. What is the sample space for this experiment? Okay. So, this is actually sort of, I'm going to set this up as a tutorial question because it would actually be quite involved. So I'm going to sort of save that for a tutorial question. Okay, we'll leave it there, sure.